In this video, I'll be recording 14 through 16 on the 3B Graph and Quadratics test review. So if you take a look at 14, 15, and also 16, you'll notice you have one in each of the three forms that we have taught you in this unit. Standard form, vertex form, and factored form. What we want to make sure that you do on every single graph is include the vertex as your third out of 5 points, and then use your table to find the two ordered pairs above and the two ordered pairs below the vertex. But that means you have to be able to identify the vertex in each form. So in standard form, recall that we find our vertex by finding the opposite of b over 2a. Then we plug that value into our function, or you look on the table to find the y value that corresponds to that x. The a value here is -1, and the b value here is -6. So if we use this for a vertex formula, then the opposite of 6 is +6 over 2 times the a value, which is -1. 6 over -2 is -3. So our vertex is going to start with -3. We now use our table, type in our function. Please make sure you have typed it in correctly, just like I'm doing. Press pause if you feel like I'm going too fast. Now look at our table, and we're going to look for the vertex, and then the 2 points above and 2 points below. So we need -3, 0. The two ordered pairs above, I'll start here with -5, -4, -4, -1, -2, -1, and -1, -4. Now what should happen is you should notice that the vertex is going to be the point in between the two symmetric points where you see the y's repeat. So even if you are not good at finding the vertex using opposite of b over 2a, if you simply go to your calculator and look for the y values that repeat, you should find the vertex right there in between. So then write that down in the middle, pick the 2 points above, then the 2 points below, graph them, connect them to form your parabola, and you'll get it correct, even if you forget this. But we do desire that you know how to find the vertex point algebraically. So from my origin, I'm going to go in the elevator by going left 3 and not moving. So that's -3, 0. I need 2 points on either side, so I'm going to go up here. So I go left 4 to get in the elevator, then down 1 floor. Next, from the origin, I go 1, 2, 3, 4, 5 to the left and down 4. Now -2, -1, and -1, -4. If your graphs do not look symmetric, then something isn't right. Go back and recheck how you graphed it. Hit the graph button, and what you graphed on paper should match what it looks like on the calculator. Next, for number 15, our function is in vertex form. We need to switch keep, or opposite keep, to identify that vertex. So our vertex is +1, -5, because we keep that coordinate. Again, if you don't feel comfortable with identifying that, if you simply type it in, then look at your table, you would be looking here in the y's to go, where do I see my y values repeat? Oh, I just saw it. Now I have 7s that repeat and -2s that repeat. Right here in the center is 1, -5. So that's my vertex, which again we just identified here. So I'm going to pick the two ordered pairs above. So my table will start with -1, 7, 0, -2, 1, -5, 2, -2, and 3, 7 to make sure that I get my vertex 2 points above and 2 points below. Clearly 422 is not going to fit on our graph, and neither is -2, 22, so we don't need those points. 5 is sufficient. So to graph -1, 7, so I'm going to go left 1 to get in the elevator and then up 7. 0, I'm already in the elevator, just go down 2 floors. Go 1 to the right and then down 5 floors, so 1, -5. +2, down 2 floors, -2. And 3 right to get in the elevator, then up 7 floors. So again, we should see that symmetry. These points, we should have this bottommost point. Should be a little more curved, sorry about that. It's just very steep graph down here. All right, and that's our parabola. The last one we have is in factored form. This will help us to identify our zeros. Remember, by setting factors equal to 0 and solving. But of course, we can do that in our head. Our zeros here are at 1, 0, so right here, and -3, 0. Our vertex is going to be at the halfway point between these two zeros. So if these zeros are 1, 2, 3, 4, 4 steps apart, then 2 is where my axis of symmetry would be. That means our vertex lies on this axis of symmetry at -1. So my vertex starts with -1. Again, if you're still not comfortable with that concept, remember you can just type in your calculator the function and look at the table for where our y values repeat. Oh, and look there, I don't have to move at all. From my last problem, I see that I didn't need to move right here. I've got 0, 0 repeating, 6, 6 repeating, so my vertex is -1, 8, which we just established that it was -1 without a calculator, but that's why. So I'm going to record in my table the two order pairs above, so -3, 0, -2, 6, -1, 8, 0, 6, and 1, 0. And I'm going to graph those order pairs. -3, 0, we already graphed because that is a x-intercept of the function. We've got -2, 6, 1, 2, 3, 4, 5, 6. -1, 8, 0, 6, which is our y-intercept, and 1, 0. Now I'm just going to connect. Please don't make them look like a V as much as possible. Let them look curved and U-shaped. And now we have our graph. We should next, of course, hit graph to make sure it looks like what it does in the calculator, and we have graphed that successfully. So that includes your test review. Good luck on your test tomorrow.